9, we see we have f of x is now equal to x squared minus 3, and g of x is equal to 2x. We want to find the area between these two functions. We don't have a graph available to us. We're going to try and do this without the graphing calculator. So that means that we need to A, find our bounds, and B, figure out which function should go first, which of the two functions is greater. Finding our bounds, what do? Yep, we're going to set the two functions equal to each other. So we have x squared minus 3 is equal to 2x. And we have to figure out what x is. Now, it's a quadratic, so we're going to have two answers, which is good because we need a lower bound and an upper bound. All right, so we have to set all these things equal to 0. We just have to get everything over to the same side. So let's subtract 2x from both sides, giving us x squared minus 2x minus 3 equal to 0. Right? Now that we've done that, we can solve this quadratic by looking for two numbers which multiply to negative 3 and add up to negative 2. What would those two values be? It would be negative 3 and positive 1. Negative 3 and 1 would multiply to negative 3 and add up to 2. So we have x minus 3 and we have x plus 1. That's equal to 0. All right, cover them up one at a time, and we can clearly see here that x is equal to 3 and negative 1. Those are our bounds. All right, so we know that we have the integral from negative 1 to 3. Next up, we have to figure out which function goes first. So we have to pick a number in between negative 1 and 3 and plug it into both f and g. I think the easiest number in between negative 1 and 3 would probably be 0, but you can obviously pick whatever number you want as long as it's in between those two values. So if we find f of 0, that's going to be negative 3. If we find g of 0, that's going to be 0. 0 is larger than negative 3, so that means g is larger than f, so g should go first. So we're going to have 2x. And then we're going to subtract. We've got to be careful here. We have to subtract the entire f function. So I have my f function in parentheses here. The quantity x squared minus 3. And the whole thing gets a dx. Right. Now that we have that, it's time to maybe simplify a little bit and then perform our fundamental theorem of calculus. All right. 2x antiderives 2x squared. And then we have minus x cubed. We have to distribute that negative sign. So that's going to antiderive to negative x cubed. I'm sorry, this is x squared. It's going to antiderive to negative x cubed over 3. And then we are subtracting the negative 3, which means really adding 3. And 3's antiderivative is 3x. So we got x squared minus x cubed over 3 plus 3x being evaluated from negative 1 to 3. So a little bit more difficult this time. No zeros and ones that we're plugging in. Got to punch in these numbers, and when we punch in 3, we're going to end up having 9 minus 27 over 3 plus 9. And when we plug in negative 1, we're going to have 1. And then watch this. Negative 1 being cubed is negative 1, but then we're subtracting it, so we're actually adding. So we have plus a third, and then we have minus 3. Right. Now again, if this is on the free response section of the exam, you are done at this point. You do not need to simplify this. If it's in the multiple choice part of the exam, that's not going to be one of the answers. They're going to want you to simplify. 27 thirds is 9, so 9 minus 9 is 0. Plus 9 brings us back to 9. So we have 9 here, minus 1 1/3, all right, minus 3. 1 1/3 is 4 thirds. 3 is 9 thirds. So we have 4 thirds minus 9 thirds, or negative 5 thirds. So we are subtracting negative 5 thirds. And 9 is 27 thirds. 9 is 27 divided by 3. So we end up having 27 over 3, double negative right there. Means we're adding. So plus 5 thirds. So our final answer we're looking at is 32 thirds. When all is said and done, 10.6 repeating. That would be the answer. If you check this on the graphing calculator, that we should come away with, that's the area between x squared minus 3 and 2x from the 2 points where the functions intersect.